Hi, welcome to my video on solving related rate word problems, and this one is extras number 4. This is the last one in the unit, but it's the last set of problems, and the next video will be on a review of the whole unit. So let's do number 1. A kite 40 meters above the ground moves horizontally at a rate of 2 feet per second. At what rate is the angle between the string and the horizontal decreasing when 50 feet of string has been let out? So we have a kite that's flying in the air, but let's write down the givens and what we're going to find first, and then we'll draw our diagram. And so what we have, a kite is 40 meters above the ground, so this the height of the kite is, I'm going to write down 30 then. The height is 40 feet. And if I draw a diagram, say this is the person on the ground, and the kite is in the air. So let's say this is the kite. So why I'm drawing this, because I want to do let the horizontal distance along the ground be x, let the height of the kite be h, and let y be the distance from the person to the kite at right angles. So that means we want to find at what rate, we're given a rate, which is dx dt. So this is the distance horizontally on the ground. So this is the rate would be in terms of x. So that rate is 2 feet per second. And the length of the string, which is y, is 50 feet. So we have a string that's let out here 50 feet. It's moving along horizontally, and as the kite moves out in relation to the horizontal, it's moving 2 feet per second. So we have to find the angle. So let's call this angle theta. So we have to find d theta dt, how this angle is decreasing. And I want to show that, just a little diagram here. So let's just look at this one, and then we look at this one. So notice, if this is the person, this is the angle theta here. If the kite is this distance away, notice as the kite is a further distance away, here this angle is getting smaller, so the angle is decreasing. So based on that, we want that angle, we have tan theta. We have to use the trig ratio of tan. Tan is opposite, which is dh, over the adjacent, which is dx. Tan is opposite over the adjacent. And again, we have a height, which is 40, and the string is 50. But because we have the height and x, that's why we're using tan. We could use sine, but we don't know what the rate here. If we use sine or cos, it won't work because we won't have enough information. So we're going to do ddt on tan. The derivative of tan is secant squared theta, and it's d theta dt. And what I forgot to do, I could do a division here, but most people would change the x, dividing by x to x to the negative 1. So that's f and g. So therefore, the derivative of h, ddt of h is 1 dh dt of x minus 1 plus f, which is h, and derivative of x, dt on the x is negative 1 x to the negative 2, and that's dx dt. So we have all this, the derivative done. So let's see if we can fill in the information. So notice I have x is here, I have theta. So it's, we can do two things. Let's see, we have a right triangle, so we have two sides, we can get a third side. So c squared is a squared plus b squared. So c is the hypotenuse, which is 50, x squared plus 40 squared. So that's 2500, x squared, 1600. So x squared, 1500 minus 16 is 900. So x is plus or minus the square root of 900. So x is plus or minus 30. But we can't have a negative, so it's 30 feet. So we have what x is. That means we have to find what secant of the angle is. And so now we have a triangle that's here. So we have a 40, and we have a 30, and a 50. So secant is the reciprocal of cos, so the cos of theta is adjacent over hypotenuse, which is 30 over 50. And that reduces to 3/5. So secant is the reciprocal, so it's 5 over 3. So the secant is 5 over 3, so we got 5 over 3 squared d theta dt. And the height is not changing, the height remains at 40. So dh dt is 0, and that's 1 over x, which is 1 over 30, plus h is 40, height, and we have a negative 1, and x is 30, so it's 30 to the negative 2, and we have dx dt, which is 2 feet per second. So let's simplify this. So that gives us 25 over 9 d theta dt. That's a 0. And this works out to be, so if I simplify this up here, I can put the answer. So that's a negative. And I have a 40. And that's 1 over 30 squared, so that's 1 over 900 times 2. So we have a negative. The zeros cancel. That's divided by 10. 2 into 90 goes 45. So I have a negative 4 over 45. And we divide d theta dt equals negative 4 over 45 times the reciprocal, which is 9 over 25. So d theta dt is 9 once, 5, so it's a negative 4 over 125. And the angle rotating, or the angle changing, is in terms of, it's a radians, and it's per seconds. The time is in terms of seconds, so this is feet per second, so it's radians per second. So that's one problem in relation to the angle of elevation, the angle of depression changing. So let's try another one. Number 2, a plane passes directly overhead, flying horizontally away from the observer with an altitude of 5,000 meters. The angle of elevation to the observer changes at a rate of a negative 0.03 radians per second. Find the speed of the plane when the angle of elevation is 60. And we're going to express that speed when we find it in, the speed is going to be in, let's see, we have meters per second, and we're going to change it to miles per hour. So here we go. So we have a given. So the given this time is the altitude, and I'm going to say A for altitude. So the altitude is 5,000 meters. And then the angle of elevation, so let's call that is changing at that rate. So d theta dt is a negative 0.03 radians per second. And again, the angle changing is in terms of radians. Normally it's not in degrees. If you had the degrees, you would change it to a radian. That's angular measure. And we want to find it when the angle is 60 degrees. The angle of elevation is 60. And what are we trying to find? Well, we're trying to find the speed of the plane. So the speed of the plane is, well, if without, let's look at it. Here's an observer, and the plane is overhead flying this way, and when the angle of elevation becomes, this is theta, so when this angle of elevation becomes 60 degrees, we have 5,000 meters of height, perpendicular, right there. So the plane is flying along here, so there's the plane. So when this angle of elevation of this plane becomes 60, so this is the horizontal distance that is flying, right here, and the speed of the plane is in relation to the horizontal distance. So the speed of the plane is, this is the distance, so the speed is distance divided by time. So this is 5,000, and I just want to draw this diagram here because the angle of elevation is right here. This is the angle of elevation. Now, so that gives us, again, tan theta is, so let's call this A, altitude is A, so tan is opposite, which is the A over, opposite over the adjacent, so it's the A over the H. H is the horizontal distance, H is for horizontal. And if we do the derivative on that, d dt, we get, oh, I'm going to make this change last time. This is A, H to the negative 1. So d dt is, derivative of tan is secant. So d theta dt. And so we have derivative of A is 1, so we have dA dt. H to the negative 1, that's F and G. And we got A, derivative of H to the negative 1 is negative 1, H to the negative 2, and dH dt. So let's see if we can fill in this information. So what we have, I'm going to look at, draw it separate here now. We have 5,000 meters. We have a 60 degree angle, so that means this angle is 30. So in this triangle is in any 30, 60, 90. So this is 60 and this is 30. Opposite to 30 is n, opposite to 60 is n root 3, and the hypotenuse is double the short side 2n. So that means that right here, this side, that means that n root 3 is equal to 5,000. That means n is equal to 5,000 divided by root 3. And that means that 2n is twice that, so it's 10,000 root 3. And so now we have to do secant. We have everything lined up. I do all this just to get to the secant. If I never did this, but I have to find these lengths in order to fit the A and the H in here, but the secant is reciprocal of cos, so the cos of theta, and I could take this one, or I could take this one. It makes no difference. Cos is the adjacent over the hypotenuse, so that's n over 2n. So cos of theta is 1/2. That means the secant is reciprocal of 2. So if I put these numbers in and work them out, so if I put 5,000 divided by root 3 and 10,000 divided by root 3 and put adjacent over hypotenuse, it would come out to be 1/2 if I work these out. But since I have these triangles similar, whatever I have in this one will also be in this one. So this is n over 2n, which is 1/2. So secant becomes 2. So secant is 2, so that's 2 squared. And the angle is negative. D theta is negative 0.03. And the height is not changing, so that's derivative is 0 times h, which is h is 5,000 divided by root 3 to the negative 1. So this is h is n, so just put that in here. So that's 5,000 divided by root 3, and this one is 10,000 divided by root 3. So we got A is 5,000. And we have negative 1. H is 5,000 divided by root 3 to the negative 2. And we got to find, I forgot to write down, we got to find the speed of the plane, so that's dh dt. Forgot to fill that in. So that's dh dt. Now we got to simplify all this. So that's 4 times negative, that's 4 times negative decimal 0.3, so that's a negative 0.12. 0 times this expression is 0, and this is a negative, so that's a negative. And if I'm going to work this out, let's work it out up here. So we got 5,000, and it's a negative 5,000. So we have root 3 over 5,000 squared. So that's 5,000, 3 over 5,000 squared. So that cancels. So I got a negative 3 over 5,000. So all that comes out to be negative 3 over 5,000 dh dt. And hence, I could move 3 over 5,000 dH dt equals 0.12. So that's dH dt is 0.12 times the reciprocal, which is 5,000 over 3. And that's decimal 12 is 12 over 100 times 5,000 over 3. 3 into 12 goes 4. Hundreds cancel. And I get 4 times 50 is 200. So that's 200 meters per second. That's how the speed of the plane. But normally we don't have the speed like that. So let's change 200. Let's change 200 meters per second. Let's change it to kilometers per hour. So I have seconds on the bottom. So I'll go with 60 seconds to 1 minute. Now I have minutes on the bottom. So I'll go 60 minutes to 1 hour. And I have meters on top. So let's put meters on the bottom. So it's 1,000 meters, and I want kilometers. So notice they're all going to cancel out. So notice the meters cancels out, the minutes cancels out, and I'm left with the seconds. Seconds there cancels out. So I have kilometers per hour. So let's cancel. I have, let's see, 200 once. Let's make that a 5. And 5 into 60 goes 12. And so we have 60 times 12 is 720 kilometers per hour. So that's the meters per second speed of plane, or 720 miles per hour is the speed of the plane. So there's a couple of problems I want to do on the angle changing derivative. That brings us to the end of the unit, except the next video is going to be on the review of the whole unit. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, the content. The content of my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.